Hello, everyone. Thank you for inviting me. I'm Andrew Beggs. I work at the University of Birmingham and University Hospitals Birmingham. I felt very old. Well, I think I made one of you feel very old earlier when somebody came up to me and went, "You were the SHO on my ward when I was the ward sister, and now I'm a stoma nurse." And I thought, oh, God. I know every time I come and give one of these talks now, people always go, "You taught me," or "We worked together during X." It's all a bit sort of, well, anyway. I'm a consultant colorectal surgeon as well. Why am I talking about this? Well, I always joke, I'm actually a molecular biologist who has a hobby of surgery. Although I have just come from the on-call, so I feel like I do some surgery sometimes. And the reason I'm involved with the Microbiome Treatment Centre at Birmingham, it's not a solo effort. It's really ably led by Professor Tariq Iqbal, who's not here today. But my lab provides the science behind it. We have found out how it works. Fecal transplantation. I'm going to give you some of the evidence behind it, why we do it, and the future directions of it, what we might use it for. I know some of you have got trains to catch, so I'm sure I'll be riveting, but I won't be offended if you need to leave halfway through. I teach undergraduates, and I'm used to them having to disappear for smashed avocados or whatever whenever I'm teaching in the university. So, I always put this on because I've spoken at SALTS lectures before. And obviously Birmingham has a proud history with SALTS. It's a Birmingham company, yeah, Birmingham. I trained in London to start with, but I moved to the West Midlands because it was much better. But SALTS have also had an association with Brian Brook, who's shown here, who was, I could say, was one of my predecessors at the University of Birmingham because he worked at the University of Birmingham as well. And he developed a simple eversion ileostomy that you all use today. The Brook constant ileostomy was this Brook, in case you didn't know. And I make a point now of telling all the SHOs and registrars that when we do the ileostomy. In fact, I did one on Tuesday while I was on call for a subtotal colectomy. So we still talk about him, and his picture's actually up outside the Department of Surgery, and so we still remember him. But we have a long and proud association with the SALTS in Birmingham, and I drive past their premises almost every day on the way to work. And so it's really great to see you all here as part of this to talk about what we've been doing with fecal transplantation. So the first reaction most people have to fecal transplantation is, oh God, because they think it's poo, why would anybody want that? But there's a long and illustrious history of using poo in curing people, essentially. And the reason is, and it's very easy to talk about healthy gut and bad gut, but that's essentially what goes on. Most people in this room will probably have had antibiotics at some stage in their lives and will have had dysbiosis as a consequence of that. So in other words, you get diarrhea, abdominal pain. And that's because, especially things like flucloxacillin, it kills off most of the gut microbiota that regulate your bowel habit. They have a synergistic relationship. And so the healthy gut, it's not just about not being inflamed, it's about having a microbiota colony that allows you to have normal gut function. And while we do FMT, it's important for it to be regulated. There was a hobby market in FMT for many years where people would go around to their neighbour and get them to poo in a bag. And unfortunately, you think I'm joking, but some people have really done that. And then they would serve it up and eat it in a drink. And obviously that's dangerous. You'd think people would realise that, but they don't always. So there's a long and proud history of it. Actually, it goes back to the 4th century. And as with most of these medical advances, it wasn't invented by anybody in the UK. In fact, it was invented by a gentleman called Gi Hong in the 4th century in China. Thanks to Nabil Qureshi, who's one of my colleagues for these slides. They're amazing. And he already started to give feces orally for people in China who had food poisoning and diarrhea. So it's been going on for nearly 1,600 years. And then we went through the Dark Ages then, as you would normally do. And they found that you could do the same thing in cows. In the 16th century as well, Li Shenzhen called it yellow soup. But that worked as well. But he fermented it even worse. He let it ferment for a bit. So he had like special yellow soup. And then in 1958, really the first time the Western world paid any attention to it was with a chap called Eisman, who gave himself a fecal enema of one of his colleagues, brave colleague. And it treated pseudomembranous enterocolitis, like C. diff colitis in 4 patients. So that's when people started to think it's a good idea. And then Bennett and Brinkman here started to deliver ulcerative colitis by fecal enemas. But as with all these things, I keep telling people in the lab, there's no such thing as new science. I'm going to show you the proof of this, that it works in real life now. But people had come well before we started to give C. diff, FMT for C. diff, and FMD for UC. So the Microbiome Treatment Centre is based at the University of Birmingham. This is the room. It's really high-tech, as you can see. It's a hood and a machine that squelches poo. And this is Sue Mansour, who's our facility lead. And it was set up in 2017 as part of something called the Stop Colitis Trial. Now, the reason it's important is we don't always think about this, but all of our medicines in the UK and in Europe are made to what's called good manufacturing practice. So what that means is it has to be fit for purpose, it has to be monitored, it has to be regulated. And up until this point, fecal transplant was a bit of a cottage industry in that people would just make some up and give it to patients, screen it, but make it up. But there was no sort of regulation of it. So Tarek and others went away and they worked with the MHRA to set up a proper licensed FMT unit that met quality control standards and had what was called an IMP and a specials license. So the IMP licenses are what allows us to give it, the specials of the IMP license are what allows us to give it in clinical trials and also in situations where it might not work properly, it's not been investigated properly. But normally this was set up, this could be given for C. diff, and it is in the NICE guidelines. But the Stop Colitis clinical trial, of which you'll see some results of it a bit, was set up to investigate people with ulcerative colitis. So what do? The donors, they get 75 questions. They get a questionnaire here. Now you may say, who's going to donate poo if they have to answer 75 questions? But we have a tactic for that. It's called Amazon vouchers. £10 a deposit, 10 deposits, £100. And you'll be amazed how many young, fit, healthy students will do anything for £10 of Amazon vouchers. But despite that, only 10% of students will actually get through the donor health questionnaire because there are various things that would exclude them. Obviously, there's the things which you would definitely expect to exclude them, such as not having hepatitis, HIV, strongyloides, and various other things. So we do an extensive bank of testing, and some of that's done within our colleagues. There's a colleague here from City and Sandwell. Some of it goes off to City and Sandwell. Some of it goes off to Public Health England at Heartlands, and some of it comes to my lab for testing. And they also have a repeat school screening, and then have a donor exit questionnaire to make sure nothing's changed. This is the bad bit, I'm sorry. How's FMT prepared administered? Now, the old school version, it's really complicated. You would get some poo, and you'd put it in a blender. And it really was just a blender initially. But you would put saline glycerol, and then you would filter out the solid particles. And then you'd use it either fresh or freeze it at -80. And we have a very famous freezer in the lab called the poo freezer, which is monitored. And this is what it looks like when it comes out like this. It's a bit more sophisticated now. We do a lot more processing on it now, but it has to be regulated processing. This is the important thing. It has to be stored in a quality assured manner. And so it's stored in these little aliquots. So when any of you request FMT, and I hope after this talk you will all request FMT for your patients, these come in these little aliquots, which can be delivered nasogastrically or via the colonoscope. So how did the FMT service start in the UK? Well, we started an FMT service with Public Health England in 2013, what Tarek did, and it sort of evolved through the years. And there are and this is actually slightly out of date. It says here that 32 out of 188 trusts perform FMT. That's actually a lot more now. And in the past, people made FMT on site, but it's difficult, and it started to get the MHRA worried that it was becoming a medicinal product. And in 2017, they classified it as a medicinal product, and it would have to be made according to GMP. And at that point, most people were making FMT pulled out in the market. And because we were doing it, I say market, although we charge, we don't make any money off it, just to let you know. We had to make sure it was made to GMP. So that's how our service evolved. So in terms of how much is being used, this is only up to November 19, mainly because, and amazingly, COVID didn't put a dent in the numbers. COVID actually, you can see it goes up almost to when COVID started. We had more than ever demand during COVID, and I'll talk about that a bit later, because of all the people on ITU on antibiotics with C. diff that was treatment resistant. So we gave quite a lot. But as you can see here, from early openings in August 18, where we were giving out 7 aliquots a month, we got up to 20 or 30, and now we're giving out quite a lot, actually. I'd say probably we're up to about 40 or 50 now, a month of aliquots being sent out. But that's for Clostridium difficile. And as I said, we do have a license to give it for other indications. So how does it happen? This is the thing. It's got a really disturbing name. It's called a stomacher, because it's basically an artificial stomach that breaks all the poo down and digests it. And this is the cabinet here that Sue's using there. And it gets put in these things here, which are labelled with the donor ID and the temperature and the storage instructions. And then it gets put in the poo freezer, as you can see here. And we send you a manual on how to administer it, but hopefully it's not too difficult to work out how to give poo. It's generally down an NG tube or up a colonoscope. So this is just the advertisement now. I will get onto the science a bit. But we do get asked this, how do I get FMT for my patient? Well, there's a hotline, the poo hotline. If you want FMT, you can call us or email us. Our details are on. If you type FMT on Google, our details will come up. And we can usually deliver FMT within the next working day in most cases. There's a form you fill in. Let us argue with your trust about the money for it. We've been there, we've done that. It's our own trust that has the most difficulty giving us the money back. But we are used to charging trust for it. And there's actually a tariff for it as well. So you will get it free of charge, but we just have to get the money back from NHS England. Now the tariff has stopped, but we are hopefully getting it back. Now this is the interesting bit. Have you ever seen the blood bikes? So they're now the poo bikes. So they're really nice guys, actually. You'll see them when I come in for about 7:30, like surgeons usually do. I always see one of these guys hanging around the fecal transplant unit, and they'll tell me they're volunteers. This is the other bit of on thing, police fundraising. They're volunteers. They do it out of the goodness of their own heart. They usually do things like retired policemen and firemen, and they buy their own bike. Sometimes they have the bike supplied, and they will drive all over the country, and they take out FMT all over the country. So when you phone up and ask us for FMT, a blood bike man, and it's usually a man, I'm afraid. There's one woman. A blood bank man will come and pick up the FMT and deliver it to your trust. Hand it to you. It's that quick. And they are absolutely superb service. So I will say, if you want to donate to a good charity, I recommend the blood bikes. And they offer that service to us free of charge as well. So why do we use FMT and why is it so important? Some of you may have heard about it in C. diff. And you've all seen patients with C. diff. And as clinicians who work with patients with bowel dysfunction, people with inflammatory bowel disease get superimpure C. diff. And especially when we give people long-term antibiotics for Crohn's-like sepsis, especially when they've had COVID, especially when they're inpatient, and especially in the frail and elderly. And a lot of you in this room will remember in the early 2000s when C. diff was a massive problem in UK healthcare. Just about everybody, it seemed, would have it, and it was raging through the population. And you can see here on the graph that there was a peak in mortality in C. diff around the 2006-2007 as we were struggling to get control over it. And you can see the age standardized mortality is 100 per million. So that's a lot. There are a lot of people dying of C. diff, and it was mainly because of the frail elderly population. But there was a hope on the horizon, and you probably won't be able to read this very much, but this sort of will give you the thing. This is what's called a meta-analysis of randomized controlled trials. So somebody had already gone out and done a lot of either randomized controlled trials of using FMT in C. diff infection. And the long and the short of it, you can see it down there, is that it's much more likely to cure your C. diff than anything else. And these are people who've had vancomycin, these are people who've had metronidazole, these are people who've had Yogurt and whatever woo they want to come out with. But the answer is it works. So that starts to make people think about what else can we use FMT for. So these are the guidelines. The bias is that obviously some of us who are in the FMT centre are on these guidelines, but it's essentially for recurrent or refractory Clostridium difficile infection. Usually decided by a gastroenterologist or a surgeon sometimes. Phone us up, say my patient's got C. diff, we will send it out to you. Now the remarkable thing is that when it works, well I say when it works, it almost always does work. In the Dutch randomized controlled trial of this, they had to stop the trial early because the success rate was over 90%, 90, in treating recurrent C. diff. And there are some of us who think for C. diff infection it should be the standard of care rather than giving antibiotics. So it's a remarkable way of treating people with Clostridium difficile. Now, why is that? Well, it's because it's a complex bias. I sort of touched on this earlier, but the gut, people like to say there are more bacteria in the human gut than cells in your body. That's not completely right. It's about 1 to 1. So there's 1 bacteria for every cell in your gut. But it's a very diverse ecosystem of different species. And we can study that in various different ways. My lab can take a feces sample. We can sequence the DNA and the RNA, the genetic code inside the bacteria, to understand what bacteria are in there, but more importantly, what they're doing. Now, the bacteria, it's amazing what some of them do. They secrete some of them secrete a molecule called butyrate, which is anti-inflammatory. And if you lose that bacteria, the anti-inflammatory goes. Some of them attract T cells that control the immune system. Some of them help secrete mucus into the gut. And some of them help synthesize, are involved with bile acid recycling, which is also important because I was talking to somebody about this earlier. As you know, bile acid is very irritating. It causes bile acid diarrhea. And lo and behold, in some of the forms of colitis, we know that a significant reason for the diarrhea is bile salt malabsorption because of dysregulated fecal microbiome. The bacteria has changed. You don't process your bile salts correctly, and you get diarrhea. So ulcerative colitis, I don't need to tell you about this. This is the slide I do for everybody, but it's horrible. It's a chronic inflammatory GI disease. It causes bloody diarrhea and abdominal pain, but more importantly, it's horrible for patients, the most important thing. It causes significant healthcare costs. And there's that, every day, there's a chap, they want me to do a subtotal colectomy on tomorrow who's an inpatient at our hospital at the moment. and it's so devastating for young people who get this. And it impedes things like their career aspirations. You can't go anywhere because you've got diarrhea. There's the fear of having a stoma. And although we're talking about stomas, and you are all stoma nurses or involved with stoma nursing, there still is, despite our best efforts, a social stigma about having a stoma. And it also impairs their quality of life, having to rush to the toilet all the time. You can give them the radar key, but these people can't go on holiday. They can't do what they want to do necessarily as easy. And it's going up. In the Western world, it's going up. And people say, oh, it's the Western diet, but we're probably not. And there are a lot of patients with IBD, 500,000 to 600,000 in the UK. And by 2030, approximately 1% of the UK population will have IBD of some form. Now, for a long time, people said it was genetic predisposition. So we know, especially in Crohn's, you can pass down inherited mutations that, like NOD2. It's one of them is called NOD2 that causes Crohn's. And if you have that genetic change, you're very likely to get Crohn's, about 4 times more likely. But with ulcerative colitis, when we've looked at where it's passed down through families, we've not really found any genetic linkage in exactly the same way. There are lots of genes that are inherited that cause a tiny increase in your risk, but not a lot. So what our hypothesis, well, Tarek and others and ours hypothesis was, is that there's some kind of dysbiosis. What we mean by that is the bad bacteria are taking over. And there are a number of reasons for that have been put forward, so I'm sorry if you can't see this about, but I'll go through it. So one of them is cesarean versus normal vaginal delivery. That was the thought. There are a lot of people who did something quite unpleasant called vaginal seeding, whereas if you were having a cesarean delivery, you would get a swab on your perineum and you'd basically rub it on the baby's face afterwards to colonize them with the microbiome from mum. Now, actually, there was a good, well-controlled study into this that showed that actually this is a load of rubbish. And just the baby being at home with mum, whether they're bottle or breastfed, which was the next one, has not really much of an impact on the baby's microbiome going forwards. So you get most of your microbiome from your family, I'm afraid to tell you. So, your children, your grandparents, your parents, that's what determines your microbiome. There is an element of host genetics we talked about. Antibiotics are a big no-no, and we know, and this is not to discourage the use of antibiotics, but good antibiotic stewardship is important, and we do know there is an association between giving antibiotics and changing your microbiome. Is there an association between the Western diet? It's a bit like smoking, isn't it? Everybody knows some 90-year-old who smokes and never gets lung cancer, and so it is the same with the Western diet. Everybody knows somebody who eats McDonald's every day and doesn't get ulcerative colitis, but there is a weak link between the Western processed diet. What there is a very strong link between the urbanized and rural communities, and what's really interesting about that is South Asian families. So first-generation South Asian families who live in India or Pakistan, there's a very low incidence of ulcerative colitis. But when they come to the UK, there is a sudden spike in the incidence, which is maintained in the second and third generation. And we in Birmingham, having a very diverse community, have a large proportion of South Asian patients with really, really severe inflammatory bowel disease that they probably wouldn't have had if they were in South Asia. And we think probably there's an environmental factor that surrounds it. So is it association or is it causation? What that means is it just that these patients have ulcerative colitis because it's actually these things are actually causing it, or is it associated with? And the way to investigate that is by analysing the microbiome, which we've done. So we've seen there are decreased amounts of these bacteria called Firmicutes and Bacteroides, and there are some nasty bacteria like E. coli and Proteobacter. But the most important thing, and I talked to you about butyrate. Butyrates are a short-chain fatty acid. So you've all heard about fatty acids in your diet, or your bacteria in your gut make it, and they're anti-inflammatory. And if you have less of the good bacteria, they make less anti-inflammatory fatty acids. And that means you have increased oxidative stress. So the bowel becomes inflamed, and that develops IBD. Now, I wish it was that simple, but there are people all over the country doing IBD research, and we're still not that much closer to having an answer. But we know from the results of the Stop Colitis trial that actually there is definitely a link to the microbiome. I feel like I'm doing a slow reveal for you of the Stop Colitis trial. You'll see it in a minute. So I promise, I know it's late in the day, we have to do some science as a scientist. The reason why people get inflamed in ulcerative colitis, one of the reasons is because of their T cells. Now, in your immune system, you have 2 types of cells, T and B cells. The B cells make the antibodies, and the T cells attack things. That's the easy way. That's surgical immunology. But there are different types of T cells. There are T cells that attack, and there are T cells that stop you from attacking. They're like the people in the nightclub going, no, it isn't worth it, leave it. And they're called T regulatory cells, and they're critical in ulcerative colitis. And when people get ulcerative colitis, one of the things we know is that they have a deficit of T regulatory cells, the cells that keep the immune system under control. So are the gut microbiota associated with this? We never knew up to this point why this was happening. So some clues came in a study that we were involved in, as you can see here, where we looked at people with a very severe form of inflammatory bowel disease from a disease called primary sclerosing cholangitis. Now, some of the audience may have seen this, some of you may not have seen it. We see a lot in Birmingham because we run a very big PSC unit because we have a liver unit on site, and a lot of these people get liver transplants. And what we found when we looked at people who had PSC UC and normal UC and just normal people, there was a difference in how their bacteria processed bile acids. And they had more bile acids, basically. They weren't processed properly and they hung around for longer. And that caused a pro-inflammatory change in the bowel. So that gave us one clue as to mechanism, i.e. if you've got UC, you don't process bile acids properly, your bowel gets inflamed and it causes inflammatory bowel disease. That's one of the causes. So the next thing was, well, can we change that? Can we do something different? And we're using FMT and UC. The studies so far, there were 4 randomized controlled trials and 25 uncontrolled cohort studies. Where the results weren't clear, there was a meta-analysis suggesting that 28% of people would work on it, it would do, but there was a lot of difference in how the FMT was delivered. The randomized controlled trials, so I think one or two trials gave it down a nasogastric tube, like you did with C. diff. 1 or 2 gave it as an enema, 1 or 2 gave it as a colonoscopy. And what they did say, however, these trials, is that the most intense response was seen in people who had it via the colonic route or the enema route. And so the Stop Colitis trial was designed to answer the question of what happens if you give FMT to people via the colonic route. There was a multi-center, I say was because it's finished, multi-center randomized controlled trial of FMT for treatment of active UC. So we randomized people into having UC versus having placebo. And the placebo was a mixture of all kinds of weird things like Coca-Cola and various other things mixed up. But the idea was to simulate FMT so patients didn't know what they were getting. And the outcomes were clinical. Is the patient better? Does it look better? You know, when you look down the colonoscope with something called the Mayo score, and mechanistic, what is actually happening? Because one of the problems with a lot of these trials, what you do in medicine, is we do a trial, we show a drug or therapy works, but then we don't bother to find out why it works. And one of the things my lab does is actually trying to answer those questions, why do these things work? So we did an open label trial where we looked at the optimum route delivery, NG versus colonic, that we completed in May 2019. What happened to patients is they came in, they had the initial FMT infusion in our Wellcome Trust clinical research facility via colonoscope, the first one, and then they came in for weekly enemas over every week for an 8-week period. We bring them in, give them the enema, lie on their side, and then they go home afterwards. They only had to retain it for as long as they could because you can't stop people from pooing. So here's the wow slide. So the response, when we gave it by the colonic arm, the response was 75%. So these were people, all people who were at the end of the line with their ulcerative colitis. They'd had 3, 4, 5, 6 biologics, some of them, as you can see here. They had been on it for a long time. They were steroid dependent. They had severe symptoms. Whereas the nasogastric arm, we only had 2 out of 8 respond. And this is the first patient, patient A. Tarek tells me he still sees this patient in clinic, and they're still in remission. And the trial finished 3 or 4 years ago. They had symptoms for less than a year. They were on azathioprine. They rapidly escalated to azathioprine. And this picture, this is before. Sorry if it doesn't project well, but it's bad. Whereas here on the right, this is after 1 dose of FMT, 1 dose. And then that response was maintained through their entire stay. It's still maintained. Now the picture here is not quite so pretty, but take my word, that's not so great. And that's a person who's got quite inflamed disease. They'd failed 3 biologics. They were heading for a subtotal colectomy. They'd had UC for 5 years. And after this, I haven't got the other photo, but they had once again had a complete response after 5 years of ulcerative colitis. Now, obviously, I'm presenting you the best patients. Not everybody has such a spectacular response. But when we talk about 75%, we're talking about a 75% complete response rate. I completely respond, their UC is gone. I know, it's amazing, isn't it? So what happens? Why is it doing this? And don't worry, I'm not going to do a quiz at the end. But essentially, those Treg tails I told you about, which hold the immune system back, they go up in the baseline to week 8. And the people who responded to FMT, they went up much higher than in people who didn't respond to FMT. And the cells that produce inflammatory mediators, we weren't sure about that. There wasn't any sort of massively significant difference in that. So as I said, we found that Tregs went up, IL-10 CD4 cells went up, and something called gut homing effector memory Tregs, it really slips off the tongue, went up as well. And they are cells as well that help regulate the immune system. And Th17 cells are another type of cell involved in ulcerative colitis we know go up, and those went down. So it was a sign that the FMT was working. So the other thing that came out during us doing the Stop Colitis trial was this really wonderfully conducted trial in India, and Tarek has liaised with these people to help them get it up and done, where they did another single-arm, open-label FMT study, very much along the lines of Stop Colitis. Their trial protocol was slightly different, but they treated 93 patients, and their outcome was steroid, because in India, where this was carried out, your options are not expensive biologics, it's prednisolone, which is cheap. And so their outcome was steroid-free clinical remission at week 30. So even in that population, which was slightly more diverse than us, 61.2% of patients had complete clinical remission with FMT, complete. And these were people who were steroid dependent. And that's been published in the Journal of Crohn's and Colitis as well. But there's a bit of a huge variability between studies. I'm sorry this doesn't project very well, but other people have tried doing this. And one of the issues is, here on the FMT route, you can see, for instance, this study here, the Rossen study, they gave it nasoduodenally, and it just didn't work as well. But as you can see, the nasoduodenal study, but some people give it an enema, and indeed, the people who had enema and colonoscopy were the ones that worked, and this one here, the nasoduodenal study, where they gave it down an NG tube, didn't work. So we now know a couple of things. One, with Stop Colitis worked. Two, it's not just because poo in Birmingham is magic. We didn't write that in the conclusion of the paper, but it wasn't magical students curing people, because it was replicated in an independent cohort in another country with a different ethnic group. And C, giving it via the enema or the colonoscopy route is the only way to give it, because it causes such profound clinical remission. So that's exciting enough. So the question was, why has this been rolled out enough yet? And because I'm saying, and this is where I'm afraid to say, and I hope the NIHR don't watch this video, when we presented the results to the NIHR, they said, oh, this is really good, we don't need to fund an RCT now. So they didn't fund the rest of the RCT, they closed it down because it was, quote, too good. So that presented quite a problem, but we subsequently secured funding to finish the RCT out. But obviously COVID got in the way. But one of the problems, you've seen this, and you're all going to want to give all your UC patients FMT, but it's not without risk. And this is one of the reasons why we're so strict here at the Birmingham Microbiome Treatment Centre about screening FMT. So this is a briefing from the FDA, and you've probably heard of ESBL producing Enterobacter, which is a nasty toxin that is produced by certain species of bacteria. And unfortunately, several patients in the US died from poorly screened FMT. They had ESBL, E. coli, and they got colonized with it and died from it. And this was because of poor screening. Now, not trying to advertise it, but we do screen for this routinely because we do see ESBL quite a lot in the West Midlands population. Also, other things, another alert showed there was a problem with other pathogenic organisms being transmitted during FMT treatment. So it's really important you donor screen. Go to a centre that donor screens. Now, one of the problems was we'd done FMT, we'd done UC, we wanted to do it, but then COVID happened. And one of the problems, and I'm sure everybody here has probably had COVID and met a patient with COVID, one of the things that people get with COVID is that 12% of patients with COVID have GI symptoms, including diarrhea, nausea, and vomiting. Now, it's very easy to say, well, that's just because they're poorly. And I'm not going to go into it today, unless people want at the end. But one of my PhD students actually looked at these people. We've sequenced their metagenome, and actually we know now what causes COVID-associated diarrhea. So that's my next thing I'm going to cure. There is actually a dysbiosis directly caused by COVID that causes COVID-affected diarrhea. But more importantly for FMT, we can detect the viral RNA of COVID-2 in the SARS-CoV-2 in the stool. And actually, ourselves and others, we've published this, have shown that in patients admitted with SARS-CoV-2, 41% of them have RNA from COVID shedding in the stool. So that presents a real problem for FMT services. And this was we highlighted this in a paper that I'll show you in a minute. The reason why that's important, if we give FMT with SARS-CoV-2, you think it's a respiratory illness, is actually the GI tract has the highest level of the receptor that SARS-CoV-2 binds to in the entire body, more than the lungs. And so if you give COVID-infected stool to people, it may well cause COVID. We don't have precise evidence of this, but we were playing it safe. So we and others wrote papers on this saying that we should stop the FMT program until we worked out what to do. And we came up with a screening strategy to screen people's stool for COVID in my laboratory. So now, when they come in, they get clinical testing, they get laboratory testing, and it comes to my lab, and we set up the world's first MHRA-accredited assay for SARS-CoV-2 testing in stool. And you may think, oh, well, you probably didn't detect any, but actually, even in young, fit, healthy donors who apparently didn't have COVID, who were PCR negative and lateral flow device negative, we detected shed COVID-2 in stool for 40 or 50 days after infection. So now we're very, very careful not to give it back to people. And so it may well explain some of the waves that we see because people are increasingly shedding in stool. So we published it. There it is. It's been published now. There, and it explains how we did it and how we would, it says awaiting peer review, but it has been published now, how we do the donor screening. We set up a sort of evidence-based protocol to screen it in stool, working with our colleagues in Public Health England to do it. So here's the fun bit. We get to talk about other areas of ongoing research. Every time I talk about poo, somebody comes and says, well, can we use poo to cure this? And the answer is poo is magic. So PSC, primary sclerosing cholangitis, there is a link between that and the microbiome. We know from the paper I showed you earlier that people with PSC have a dysbiosis that could be treated by FMT. So I'll talk more about that in a bit. Now, more importantly, checkpoint inhibitor colitis. Now, some of you may or may not have encountered, especially those who do bowel cancer, we're giving people things called checkpoint inhibitors more and more now, PD-1 inhibitors for people with lung cancer, bowel cancer, melanoma. And about 10% of them get a terrific, horrible colitis that could be life-threatening. In fact, I've taken out 2 colons of PD-1 colitis at our own trust in the past 3 years, and it's nasty. They get really sick, and that is due to PD-1 inhibitors make the immune system switch on. They get hyperactive, and that's what kills the cancer, but in some cases, it kills the colon as well. So as part of our specials license, which we've got, we have given people with PD-1 colitis FMT, and it's cured them. It's fixed the problem, and they don't need their colons out. However, because we're not American, somebody in the New England Journal of Medicine wrote up one case where they'd done it and got it in the New England Journal of Medicine, and we didn't beat them in time, so it's old hat now. But we have offered that, and we have given it to people. Pouchitis is another problem. You will all have seen in the audience people with ileoanal pouches. We are trying desperately to get the Stop Pouchitis trial, original names, set up, where we're going to give FMT to people with Crohn's disease, with UC who've got pouches. We have some very anecdotal evidence it works. My favorite one is a surgeon called Des Winter in Ireland who had a patient with pouchitis for over 20 years. He was on cycling, ciprofloxacin, metronidazole, nothing worked. He came to see us in Birmingham. Out of desperation, we gave him FMT and all his symptoms have gone. Anecdote, admittedly, but we've had, and endoscopically, all his symptoms had gone as well. So we desperately want to run the Stop Pouchitis trial to try and help some of these patients. Now, Crohn's disease, there's variable evidence, and somebody in the audience asked me earlier about Crohn's disease and UC. We want to do this in Crohn's disease as well, but the spectrum of Crohn's disease is very variable. Things like Strickling disease, which we'll never be able to reverse with FMT, and the biological pattern of it means that a Crohn's disease FMT trial is a little bit off. Now, non-alcoholic fatty liver disease is another one. Amazingly, you get a dysbiosis from that. So that's basically where your liver gets infiltrated with fat usually it's because they eat too much fat. It's not very sophisticated. We think there's probably a microbiome effect there. But more interestingly, we've also given it to people with diversion colitis. Now, that's a real problem for a lot of stoma nurses who treat patients. We had one patient down the road at Warwick, actually, who had a defunctioning ileostomy and got terrific diversion colitis, like severe diversion colitis. And we had a meeting, we had a discussion about it. We run a multidisciplinary team for difficult cases like this with microbiologists, surgeons, gastroenterologists. We had a long chat about it. And we decided to give, and she was in hospital for 6 weeks with this diversion colitis. We decided to try and give her FMT down the ileostomy loop, distal limb. She had 1 dose of FMT down the distal ileostomy limb and the diversion colitis disappeared, gone. And it's been maintained as well in her. She just keeps coming back for top-up infusions. The final one that's exciting is pseudo-obstruction. These people are really problematic. They're usually residents in longer-term nursing care who come in with distended abdomens or neurosurgical patients who've had instrumentation of their spine. And tantalizingly, a Chinese study, a randomized controlled trial, has given people with a pseudo-obstruction fecal transplant and had a cure rate of about 70 to 80%. So we think there's probably a trial there as well. But we can only write trials as quickly as the NHR will fund them. So we're hoping to do one on that. But then number one that's coming, well, PSC one's already funded. And this checkpoint inhibitor colitis one's already funded. The next one that's coming is Stop Pouchitis, because that's a real problem at the moment, pouchitis. And ourselves and some Marks and others are just working that up at the moment. We've talked about it in the media as well. Tarek talked about this article in The Guardian, if you're interested. The poo panacea, the patient you saw there is actually in this article, with that response there. So you can see what a difference it's made to their lives. But we've also got a PSC trial for people with PSC ulcerative colitis. It's called Fargo. And it's run by my colleague Palak Trivedi, who's a hepatologist at our trust. And it's the first one. It's going to use FMT to treat a non-GI disease. So people with PSC have ulcerative colitis as well, PSC-UC. So we're giving it for that. But we think the reason they get PSC itself is because of the dysbiosis. So it's a multi-center randomized controlled trial of FMT versus placebo. And the primary outcome is whether their liver function tests get better, not about their diarrhea, but whether we can fix their LFTs with FMT, which we think we probably can, given what we saw in that previous study. And it's funded and it's opened at UHB. I think I saw the letter the other day in our trust, and I think it's opening at other trusts around the country. And we will be delivering the FMT to these trials as part of that. And if that's the case, if we can make a difference to PSC patients, the reason it's not important is not just from the point of view of stopping them from getting UC, it's because these PSC patients, the destination for most of them is a liver transplant. And that is an extremely, a liver transplant costs the NHS £1 million. We do about 200 to 300 a year in Birmingham. And although the liver surgeon would hate me for saying this, a liver transplant is not a great option if you can avoid it. So if we can try and modulate people's chance of getting liver failure by reducing their PSC burden with FMT, so much the better. So in conclusion, I hope you've all enjoyed that. FMT is a really vital thing for UC. It's underused. And we know from our observations it may prevent progression to surgical intervention. The trouble is now getting it from the stage where we know it works into a therapeutic. One of the exciting bits of news I can share with you, but I haven't put on here because it's going to patent, is that we've identified the bacteria within FMT that's actually responsible for the progression. Bacteria, there are 10 of them. And so we're working with manufacturers to license it into a pharmaceutical, so you don't need to give poo. You can just grow it in vats, and you'll be able to give them a therapeutic enema that you keep in the fridge, which will be a lot easier than collecting feces and giving to people. So we're putting ourselves out of business. It's got better side effect profiles than many therapeutics. The side effects of poo are extremely minimal for patients. They don't really have any side effects we've noticed, apart from feeling a bit icky about it all. But the question is whether in the future we should be moving it to first line, in that instead of flogging people to death with azathioprine and steroids, whether we should think about giving them FMT as first line. Because it's so simple and so easy, and it may well prevent them from getting a lot of horrible complications they can get with UC. So thank you very much. I'd just like to do a big up for Birmingham, everybody here from Birmingham. Thanks to the merger in Heartlands, we're now the UK, Europe's biggest combined gastrosurgical unit. We've got 27 consultant surgeons, colorectal surgeons, and 30 consultant gastroenterologists. We're huge, which means we get a lot of interesting patients to play with. And just to prove to you the sun does shine, those of you who are not Birmingham, this is the hospital looking all shiny, one of our hospitals looking shiny there. And there's the university here, so it's not all Mordor and Gollum and horrible concrete jungles. Birmingham is actually a beautiful city these days, and I encourage you all to visit it. Thank you very much for your time.